This is under set theory, some of the things that I would like you to know. Yeah, so these questions are actually examined for what is, they usually come in test ones. So we have the following saying, given that x, y, and z are sets, simplify the following. So you have x complement union y intersection z, then we have a complement outside. Now guys, I want you to know this. Whenever there's a complement outside, okay, whenever there's a complement outside, like there are brackets here and here, whenever there's a complement outside, you can take it inside. And I would like to mention this, there are only two sets here. There is this set and there is this set, okay, and this is what is dividing them. So there is x complement as a set, union y intersection z. So there are only two sets, this one and this one. So if I push the complement inside to this set and to that set, it will come here and it will also come there. Now when it comes here, it will cancel out with this complement and the complement will disappear. So in other words, complement, it will disappear, right? I'll have no complement. Okay, so that's what I'm going to do. Okay, and one of the rules that you have to know is some rules that you need to know is that A complement, the answer is A. In other words, when two complements meet, right, they're multiplying each other, the answer is no complement, right? There. Then the other thing is, whenever you have maybe say A, right, intersection B, then the complement, for example, what I give, you have something like this, A intersection, right? Of course here there's another set, but I don't want to write another set here. Just want to say A complement, then there's A intersection complement, right? Though this is supposed to be another thing here, it's supposed to be like B, but I don't want to, there's something I want to say. I'm avoiding that. So the complement will come to A, right? I'm going to have something like A complement, right? But this computation next to it will change to union, so it will become union. So if it was union, it will become intersection. I hope you get. In other words, this here will change. Okay. So whenever there's a complement outside, it has to go inside. That's how you simplify this. So let's continue now. So we have a complement here. So the complement will go to x complement, then the complement will go there. Then this sign next to it will change. Since it is u, it will change to intersection. Then y intersection z what? Complement. Okay, now this complement will go inside. When it goes inside, now I have to take the complements inside. When it goes inside here to cancel, so I'm going to have complement. I'm going to have x only. So I'm going to have x intersection y, okay, y, and please don't change this, it has already changed, okay. So y complement, I'll take now also this one, I'll take it inside. Now when I take it inside, it comes here, right? This guy has to change, the guy next to it has to change to union, okay? And it also has to go to z, okay, like that. Now from here, you can now take this one inside, so this would be x intersection y complement. But even this is the answer anyways, you can just even end it there. There's nothing much there, okay? There's nothing much. Alright, then guys, there's some rules I would like you to also know. So simplifying this further, it will be x intersection y complement, okay, union x intersection z complement. In other words, you multiply this with that, again this with that. All right, so now there's something that I want you to know, some again rules that I would like to write, okay. This you can write down. In other words, the first one of course is A complement, the answer is A, of course. Then the other thing is, the second one is A intersection empty set, okay. What is the intersection? What is the answer if you intersect a set with an empty set? The answer will be empty set. Then the third one is A union empty set, the answer is A, okay. Then the fourth one is A intersection A, If you intersect a set with itself, the answer is A. The other one is if you intersect a set with a universal, E, the answer is A. Then A union A complement. A union A complement means what is in A plus what is not in A. The answer is what? Is universal. And then the seventh one is A union universal. The answer is universal. Then the other one is I can put it here. The other one is the eighth one is A intersection A complement. The answer is empty set. You need to write these, you need to know them, and I can explain them better. Like for example, here I told you like A complement, the complements will cancel out, right? We're going to remain with A. Now here, if you intersect a set with an empty set, what is intersection? Intersection means something that is common, right? So like something that is found here, right? So you are trying to intersect a set with an empty set. What would be the answer? The answer will not be A. The answer will be empty set. Why? Because an empty set is a subset of all sets. So if I told you to list set A, if A was 1, 2, 3, right? Then I told you saying list set A. Your list will start with empty set. Empty set will start with empty set, comma 1, okay, comma 2, comma 3, etc., etc., right? So every set has an empty set. So A has an empty set. So those two empty sets will intersect, right? That's how it is. Then the other thing is A. Let me explain it further as well. A union empty set. What is A? What is set A plus an empty set? The answer is set A, right? Good. And what is A intersection A? So if you intersect a set with itself, the answer is what? A. Okay. Then what of A and the universal? What if you intersect the universal with A? So if set A is 1, 2, 2, 3, right? Then the universal is 1 to 10. 1 to 10, right? Have you noticed that this will also be in there? In other words, the universal is the totality, right, of everything. Then intersection means what? Something that is common, right? So meaning if you intersect any set with a universal, the answer is that set. I hope you get it. Like the answer is just that set, because the universal set is a totality, right? The universal set is everything here. That's a universal set. All right. Now, what is set A? Set A is here. I'm sure you get what I'm saying. So the intersection, if you intersect any set with a universal, the answer is the same set. So B intersection universal, the answer is B. C intersection universal, the answer is C. C. All right. So let's go to A union A complement. So what is A union A complement? So notice, if you have this as a set A, right? If you have this as a set A, this is a set A, then this is your set B, right? If I told you to say shade set A, right? Shade is B this, right? What if I told you saying shade the complement of A? The complement of A would be is everything here. So union, if you add everything together, what are you having? You're having the universal. So whenever you have something like X union X complement, the answer is the universal. B union B complement, the answer is the universal. In other words, if you bring what is in this set plus what is not in the same set, the answer you have the universal set. It's like you're saying what is in A plus what is not in A. You're just going to have the universal, as I've explained there. Alright, what of A plus the universal? That is just the universal, you know, because if this is a universal, A is also found in the universal. Do you get the sense? A is found in the universal. So there's nothing that you can add to it. Alright. Now what if you intersect, like for example here, A intersection A complement? The answer will be empty set. So if this is your A, if I told you saying this is your A, B, this is your A and this is your B. If I told you to shade set A, it's here. If I told you to shade what is not in A, and I'll use red pen, it is here. This is what is not in A, right? Do you have anything intersecting? Nothing is intersecting, right? Nothing is common. What is in here, that doesn't mean it's in A. No, nothing, right? So the answer will be empty set. So whenever you have something like x intersection x complement, the answer is empty set, because what is in A is not found in A complement. There's nothing that is common between these two except the universal set. So if you have y intersection y complement, the answer will remain empty set. I'm sure this has been of help. So I'll dive into these questions as soon as possible.